Hi guys, and welcome to another video lesson. In today's lesson, we're going to be looking at grade 12 maths sequences, geometric sequence, finding n in the geometric sequence, the sum to infinity, and a proof of sum to n terms of an arithmetic sequence. The question that we're going to be looking at is from the February-March 2018 exam paper. The question reads as follows. It says, given the following geometric sequence 30, 10, and 10 over 3, determine n if the nth term of the sequence is equal to 10 over 729. Also says calculate 30 plus 10 plus 10 over 3. So we want to find the sum of this particular series. And the next question says, derive a formula for the sum of the first n terms of an arithmetic sequence if the first term of the sequence is a and the common difference is d. So this is what we have to do in this particular question. So let's go and answer the first question. First of all, in a geometric sequence, remember that we are going to have a constant ratio. Therefore, T2 divided by T1 is going to equals to T3 divided by T2 and so on. Also, what we have to know about a geometric sequence is that the formula for the nth term is equal to Tn equals to A, which is the first term, times R, which is the ratio, to the n minus 1. So we're going to be using this particular formula to solve for n. And remember, they're telling us that the nth term is equal to 10 over 729. So basically, they're giving us Tn and they want us to solve for n. So let's see if we can solve this first question, 2.1.1. It's important for us to do the following as well. Set out your sequence properly, 30, 10, 10 over 3. So we'll get 30, 10, and 10 over 3. So let's write Tn, that's the sequence. N is the position of the sequence 1, 2, and 3. And don't forget here that they tell us that Tn, which is the nth term of the sequence, is 10 over 729. So 10 over 729. So the ratio, we can work that out, or R, will be 10 divided by 30. 10 divided by 30 is 1 over 3 simplified. And if you want to double check, 10 over 3 divided by 10, use your calculator to double check if you want to. 10 over 3 divided by 10, and we should get exactly the same, which is 1 over 3. So that's also going to equals to 1 over 3. So we have a constant ratio, and they told us that it's a geometric sequence. Therefore, our next step would be to write down the formula. Tn equals to AR to the n minus 1. Let's substitute what we were given. 10 over 729 equals to A is the first term of our sequence, which is 30, times R is our ratio, which is 1 over 3, to the n minus 1. So let us now solve for n. Now this becomes an exponential equation and we're going to solve for n. Remember that in an exponential equation, we want to get a common base on both sides. Because when we get a common base on both sides, then the bases fall away and we can equate the indices. So let's get rid of this 30 in front here. So we're going to say 10 over 729 will be 10 all over 729. We're going to divide by 30. So basically we're dividing both sides by 30. Let's just write that down. Okay, so what's that? 1 over 2187. So 1 over 2187 equals to 1 over 3 to the n minus 1. So what we require now is to write 1 over 2187 as 1 over 3 to some power. So now let's just go by process of trial and error. So let's look at that. So 3 to some power, because remember we went 1 over 3 And we know that, for example, 1, you can have 1 to any power will give you 1, right? So let's look at 3 to the process of trial and error. So let's look at 3 to the 6, 729. 3 to the 7, 3 to the power 7. What's that? 2187. Okay, so we got it. So therefore, that will be 1 over 3 to the 7, 1 over 3 to the n minus 1. So what do you notice? Well, you can test it out here. 1 to the 7 is 1. 3 to the 7 is 2187. 1 over 3 to the n minus 1. We've got a common base on both sides. Therefore, the bases fall away. You can equate the exponents. So 7 equals to n minus 1. Therefore, take minus 1 to the other side. N will equals to 8. So n equals to 8. Therefore, it is the 8th term to conclude. That's our solution for the first question. Let's look at the next one. Next question says, calculate 30 plus 10 plus 10 over 3. So here they want us to find the sum of the series. So the sum of the series. Now, when we set out our sequence, you'll notice one thing, that r is 1 over 3. Basically, r is between minus 1 and plus 1. Therefore, the sum to infinity exists. The sum to infinity exists. So what they want us to do in this question is to find the sum to infinity, because r is greater than minus 1 and less than 1. So therefore, 2.1.2 is going to be the formula for sum to infinity is a all over 1 minus r. A is the first term, which is 30 all over 1 minus, and our ratio is 1 over 3. 1 over 3. Let's put that in our calculator. 30 all over 1 minus 1 over 3. That's equal to 45. So therefore, our sum to infinity is equal to 45. Let's look at the next question. In the next question, it says, derive a formula, the sum of the first n terms of an arithmetic sequence if the term of the sequence, first term of the sequence is a, and the common difference is d. So for 2.2, this is the proof, one of the proofs that we need to learn for the examination. So therefore, my first step would be to expand the sequence of the sum to n terms of an arithmetic sequence. So I'm going to write it as follows. So the first term is a, second term will be a plus the common difference d. The third term will be a plus 2 times the common difference d, and so on, plus, and the second last term will be a plus n minus 2 times d, and then the nth term will be plus a plus n minus 1 times d, and I'm going to call that equation 1. Now let's write our sequence in reverse. So therefore, writing it in reverse will be Sn equals to, let's start with our nth term, a plus n minus 1 times d, plus the second last term will be a plus n minus 2 times d, plus, now let's go back to our third term, which is a plus 2d, a plus 2d, plus our second term is a plus d, and plus a, which is our first term, and we'll call that equation 2. So firstly, what we've done here is we've written it in forward and in reverse. So we're going to add both equations. Now we're going to say equation 1 plus equation 2. So we're going to add. If we add both, Sn plus Sn is 2Sn equals 2. And if we add over here, we're going to get the following. We get 2a plus n minus 1 times d plus 2a plus n minus 1 times d plus, so this is going to continue, 2a plus n minus 1 times d to n terms. Therefore, we can now write 2Sn equals to n into 2a plus n minus 1 times d. Now if you divide both sides by 2, you get Sn equals to n over 2 into 2a plus n minus 1 times d. This formula is the formula to find the sum to n terms of an arithmetic sequence. That is, if you haven't subscribed already, subscribe to JL Maths. Also like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.